Hi everyone, welcome to the Bell the Cat series of videos. My name is Tony Xavier and I'm the Chief Learning Officer of IMS. The Bell the Cat series of videos, as I keep saying, is a set of companion videos to my book called Bell the Cat, which is available on Amazon. This is the first video on Quant called How to Solve a Quant Problem. Let's see the basic steps. When you look at a quant problem, what is the usual process followed by all students? Read the question, and as soon as you read the question, you start noting down information. You're reading and parallelly making notes. Second thing is, somehow use algebra. If you can frame an equation, if you can take the distance as d, you feel the job is done. Matlab, I frame an equation and then we live happily ever after becomes the whole idea. You solve for x, whatever equation you frame, and you mark the answer. What is the problem with this approach? The first thing is, solving as you start reading means that 9 out of 10 times your solution is suboptimal. Why do I say it is suboptimal? How can you start a particular approach without knowing the full information, right? So if you're starting to solve as soon as you start reading, the solution is going to be suboptimal. No great, excellent test taker or problem solver that I see ever start solving without knowing the whole situation. Partial information, always dangerous. Next one, you solve for x, you look at the answer options, you find the answer, you mark the answer. Then it turns out it's wrong. Why? Because as soon as you started reading, you took something as x. But the question is asking for something else because you found the value of x, and the question setters are also very sharp. They know this. They know that in the process of solving this question, you will find 2-3 different values, right? They're asking for one. The other two also, which you will determine, will be there in the options. And if you make a silly mistake, you will go and mark that. So they will lay out perfect banana skins for you. You are thinking, silly mistake. But I will say, it's a process mistake. It's not a silly mistake. Because if it's a silly mistake, then all I can say is stop being silly, right? If you're always falling on a banana skin, you can't say it's a silly mistake. It's a process mistake. You're not looking down when you're walking. Yeah. So what should you look at? How do you solve a quant problem? Why is it like this? The main thing is, all of our lives, nobody said, irrespective of what maths problem you're solving, these are the 5 best practices, right? So everybody has taught us solutions, but not how to solve problems. We have been given fish, but not how to fish, right? Irrespective of it, right? So we are looking at what are the best practices to solve, but I feel that for any sphere of life, right? It can be cricket, it can be, it can be sports, or it can be cooking also. And math, there are always some best practices. And these best practices ensure that 9 out of 10 times when you do something, the output is really, really good and everybody will like it. It can be quant or it can be cooking. I don't see any difference in the two because there are a series of steps always that great cooks and great problem solvers always do. So let's look at what are the steps here. The first and most important, in terms of mindset, I feel this is very, very important, is that writing is not thinking, right? The moment we see a problem, it's almost as if as soon as we read, we start writing. So I remember, for the longest time, I've been based out of Bombay. Only recently I've moved out of there. So one of the weekends I usually used to go out to town in Churchgate in South Bombay. And after that, I would get back. So that was my usual place. I would take walks around that place. I really loved walking there. So I'm getting back. I'm at the train. It's the train station. It's the starting station, Churchgate. Train is there. All compartments are empty. I go in and I sit by the window. Suddenly, I see one guy dashes into the train. He's looking here and there, and suddenly he rushes into a corner and sits. Now, imagine the scene. Train is empty. It's not going anywhere. There is only me there, but that person is acting in an absolutely desperate situation. Why? It's not that person's fault, because in Bombay, people are conditioned to rushing for a train and finding a seat. That has become their habit, right? Unfortunately, life is tough there. That is why, right? Similarly, with maths problems, the moment we see a math problem, it's a Pavlovian response that you start writing, right? But writing and thinking are two separate things altogether, right? In verbal, we read, we don't think, we directly mark. We're just going through the whole process, right? There is no stop to do a set of thinking processes. In quant also, you read and you straight away start to write. So the most important thing, writing is not thinking, writing is writing. Yeah. So that is a big change that you'd have to make in your head. Yeah. Next one. So once you know this, and once you stop, see, like in cricket, they say the initial movements are very, very tricky as to that ends up making or breaking this thing. For example, Virat Kohli goes onto the front foot. He likes to get forward, right, rather than play beside the ball. So, which is why there is always a bit of a technical issue in the sense that getting caught in the steps. So your initial trigger movements, that trigger movement itself is going to set you up either to succeed or to fail. But if you look at, say, some of the batsmen like Travis Head, for example, or even Sehwag, they always stay beside the line of the ball and they keep carving the ball away, right? So that initial movement of writing, if you can stop, that's the golden rule. Then you will see that everything else will start falling into place. First rule, read the question fully. Do not put pen to paper. What are the key reasons? What are the things not to do? Do not copy information that is already present in front of you. Either on a paper-based test or in a computer-based test, that information is there. X can do a piece of work in 20 days. Yes, X can be a 2. Why to write X is equal to 20? That information is there. You can remember that much. There is no point writing that down. Second is, do not draw simple inferences and write that down. For example, X can do a piece of work in 20 days. One day, 1 by 20. Yeah. If he can do a piece of work in 20 days, you know that one day, 1 by 20. You've just read one sentence. This does not take you any closer to solving the problem, right? You might not even need that 1 by 20 thing, right? So don't do these initial things. Yeah. Most importantly, information is not given to you in sequence. Question setters deliberately give you information in a non-linear format. The most important piece of information or the twist in the tail can be at the end. If so-and-so is so-and-so, so-and-so, then what happens? Until then, the information has been given, right? So you have to understand the nature of the question setter and how they're framing questions, and then know that because it is framed that way, they are not framing it in a linear fashion. There is no point for me to start solving. First thing, read the question fully and do not put pen to paper. Next thing, this is a very, very important step. We read, but do you really understand what the situation is, right? So then step 2 is to always say, okay, what do I have and what do I need? Right? This is all that is given to me, right? And if this is given to me, maybe I can easily calculate this also. That is also part of what do you have, right? If I've given X and I've given the cost price and I've given the profit percentage, then I can calculate SP. So straight away you know that SP also you have, right? So that is what you're supposed to do. So do not solve. So after reading the question, do not solve by starting by solving what you can. For example, you see an equation with a square. Let me expand that square. Why? You can expand something. Do not do what you can. You need to do what you should. There are many things that you can blindly do in terms of steps the moment you read a question. So read the question fully. Do not put pen to paper. Think for yourself. What do I have and what do I need? Right. The next step is, how do you build the bridge between what do you have and what do you need? That is very, very important in terms of how do you build that bridge. Yeah. So, do you take the variable as X, 100 or some other number? What is the best situation or best strategy in this particular situation, right? So maybe if you see that the numbers that you need to take should be an LCM of 6 and 7, then you should take a number accordingly, maybe 420 or 4200. Right? That makes more sense. So, or maybe you say in this case, why to take X? 100 is better. So that, should you even solve? Or should you say that, let me take n is equal to 1, let me take n is equal to 2. Should I plug numbers into the equation and get the answer? Is that a better way to build a bridge? Okay, the way the answer options are given, the answers are very, very far. So should I actually need to calculate precisely, Or can I do some approximation? Because if the answers are 20, 30, 45 and 58, they're fairly far. Right? At the same time, the answer is 25, 26, 27, 28. You know that, okay, I have to calculate precisely. Next one, should I actually solve backwards? Should I use the answer options, substitute in the question and get, is that a better method? How do you build that bridge? Right? Now, once you do that, then you go ahead and put pen to paper and write only what is required. Right? This is absolutely important. Minimize the steps written. Do some steps mentally. Right? I discussed this in that 7 skills to crack the cat in terms of solving efficiency. That is the 4th skill that I mentioned there in the 7 skills to crack the cat video in this same series of videos. In that, I mentioned that writing steps, if you have in school and college exams, there are marks for steps. There are no marks for steps. So every time you write a step, you are slowing down the whole process, right? If you write all 10 steps, then you're slowing down the process. On every question, if you can shave off half a minute, and if you're answering 10 questions also, that's 5 minutes more and 2 more questions you can answer. And that's the difference. Maybe you know that the numbers are very small. If you look at the percentile data, I'll show you the percentile data in the strategy videos that I do, but you will see that just 1 question more can be a 5 percentile jump, right? From 80 to 85, right? So minimize the steps written, do some steps mentally, right? Most importantly, a lot of students make calculation mistake. Why do they make a calculation mistake? Now you know how to solve. You're already thinking, let me quickly solve and go to the next question, right? You're in a hurry and there you'll make a mistake. Right? So calculation mistake is like in cricket. If you get run out, no, without grounding your bat is in the air. Right? That's the silliest thing to do, right? You have to ground your bat. So I always keep saying that when you actually do running between the wickets, the 2 best people, at least, no, not just too many are there, but the 2 best people are Kohli and Dhoni. They're always looking at the field, running fast and grounding the bat. When both of them were at their prime together, it was fantastic to watch how they pinched those 1s and 2s, right? So do not take your steps. It does not mean that you're slow. Right? Are they running very, very slowly? No, they're running fast and they're grounding the bat. So don't take your eyes off the calculation. Another example I'd like to give, I don't know how many of you, all of you would be aware of Rajnikant, but maybe all of you might not have seen quite a few of his movies. So I was born and raised in the South. So I've seen his movies. So anytime Rajnikant gets off the stairs, there would be movie scenes where he's getting down the steps. How does he get down? He stands crossed like this, right? He doesn't stand straight, he stands crossed. And he gets down, tuck, 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 tuck. Super fast. Is he jumping steps? No. But is he getting down fast? Yes. Every step is landing. So that's the best example I like to give. Do the calculation super fast. Every step should land. Your focus should be there. Yeah. Last part. Before marking, check what is being asked. You've done everything correct. Maybe you've taken the right thing only as X. To solve that problem, that needs to be taken as X because that is very, very efficient. But what they're asking is something else, right? Something related to it in a different order, and hence you need to check, right? So I was discussing, not for this video, but in general, that we should make this part of our teaching, how to solve a problem. I was discussing this with a colleague of mine who's a serial 100 percentiler on CAT Quant. He's one of the best guys in the country with respect to CAT math and, any conceptual clarity, you just ask him. So after this latest CAT, he called me and he said, and after the result came, so we were discussing this before marking, check what is being asked as step 5, for all students. And after that, they released the answer key, and he called me and said, sir, I'm calling you because, I know you'll understand, I can't tell this to anyone. Exactly this happened in the exam. I solved the question. He got only 2 questions incorrect out of the entire, set of questions. So he's like, I solved the question. The whole question was in the format of acid water. But finally, when they asked right at the end, say, what is the ratio of water to acid? So he got 3:5, but what they asked was, 5:3. Acid water or, water acid. So at this level, you see, even somebody who's a 100 percentiler on the quant can end up making this mistake. So just that small thing. Okay, I got acid water. What are they asking, right? So for example, it is best to calculate, go with the problem by taking the cost price as X. That's the best way to go, right? And you've calculated X. But maybe they're asking for the mark price, maybe you're asking for a selling price, right? So if you see, what are these 5 steps? I've just given you 5 steps that work for any problem to solve, these are the best practices, right? Doesn't matter what topic you're looking at, doesn't matter what formulas you're using, yeah? So we'll take about 5 to 6 problems and we'll see how to solve a quant problem using this. Now, obviously, there are so many variety of questions that it might not be exhaustive. The idea of these solved examples is for you to get a peek into the process and for you to start making this a habit. Yeah. Now, guided practice of how to solve a quant problem. I'll show you a problem, pause the video, think about it for a bit, and then we'll go to the solution. Yeah. Right. Two cars travel from different locations at constant speeds. That means the cars are not changing speed in the beginning. Doesn't mean both cars are the same speed. The cars are not, speed is not changing. To meet each other after starting at the same time, they're taking 1.5 hours. So if they're different positions, they're starting at the same time, they meet after 1.5 hours. But if they're traveling in the same direction, that means one car is here and the other car is here, and both are going like this, they take 10.5 hours to meet. What does this mean? That means the car that is behind will take so many hours to catch up, to cover this distance and meet. So definitely from here only we know, if the car behind is the slower car, can it ever reach up to this car in front, which is a faster car? No. So that means the faster car is behind, the slower car is in front when they're traveling in the same direction, and it's slowly making up the time, 10.5 hours. If the speed of the slower car is 60 kilometers per hour, then what is the distance traveled in kilometers by the slower car when it meets the other car while they travel towards each other? Classic cat problem. No, I think two cars and towards each other, opposite to each other, is one of those things that has to happen. Now you look at what do you have. First one, time taken to meet each other in opposite direction you have. How much is that? 1.5 hours. Time taken to meet each other, same direction. How much is that? 10.5 hours. Speed of the slower car is how much? 60 kilometers per hour. You have that. What do you need? Distance traveled by the slower car in the opposite direction. When they're traveling towards each other, what is the distance traveling by the slower car, right? This is again an actual cat problem. So, we're looking at actual cat problem. How do you build the bridge? Do you actually need to build a bridge? You don't need to build the bridge. You can actually walk the distance. Why? Because distance is what? Distance is speed into time. How much time is it traveling for in the opposite direction? 1.5 hours. What is the distance? What is the speed of the slower car? 60. So you know the speed, you know the time. Distance is nothing but speed into time. 60 into 1.5, 90. Right? You have this distance is speed into time. You have the speed 60. You have the time 1.5 hours, and the answer is 90. Right? Did we write any equation? No. Is this a problem which is like very elementary and does not come on the cat? No, it's an actual cat problem. But if you looked at the whole thing and tried to solve it by let the distance be d, these two cars are here and let the distance be d, you're done for, right? Then you take that distance and you're trying to form all sorts of equations, doesn't really work. Yeah. So answer to this, 90 kilometers. We've seen the clear steps. What do you have? What do you need, and how do you build the bridge? Consciously try to do this for the next problem. I'll show you the video, pause for a bit, try to do this, and then go ahead. Brishti went on an 8-hour trip in a car. 8 hours Brishti is traveling. Before the trip, that car had traveled a total of x kilometers, right? Where x is a whole number and is palindromic. So there is a meter reading at the beginning in the car. And this meter reading is palindromic. What is palindromic? Palindromes are numbers or words where on both sides, when you're spelling them, both sides, if you read from right to left or left to right, they're the same. For example, 3003 is a palindrome. The word Malayalam is a palindrome, right? From left to right or right to left, same this thing. So they're saying this meter reading is a palindrome. At the end of the trip, the car had traveled a total of 26862. If you see same number from left to right and right to left, this number again being palindromic. If Brishti never drove at more than 110 kilometers, then the greatest possible average speed at which she drove during the trip was. Okay. Now, what do you have? Meter reading after the trip. 26862. What else do you have? Time traveled for 8 hours. Meter reading before, you know that is also palindromic. So you know that meter reading after, you know time travel, you know meter reading before. What do you need? You need the speed of travel. That is what you need, right? Now, how do you build the bridge for this? You know that meter reading after minus distance traveled is equal to meter reading before, right? So there is a meter reading minus the distance traveled is meter reading before, which is a palindrome, right? Now, you know that 26862 is the meter reading after. You don't know the speed, which they're asking you for, speed, but you know the time, 8. So meter reading minus speed into 8 is equal to meter reading after, which is a palindrome, right? So that is the whole this thing. Now, if you look at this, how do you build the bridge? You know that the key thing that after this also it has to be a palindrome. So how do I get the speed? Can you calculate the speed? Is there any other hook there? No, because you cannot imagine palindromes, right? You cannot take some random palindrome and you cannot say that, for example, it should be some number less than what you call, this particular, number, 26862. So it has to be something which starts with 2, but you don't know it can be less than 2, impossible to solve, right? But it has to be a palindrome. How do I get the speed? This is when you think of, whenever there are answer options, you have to consciously think, can I use the answer options? The answer options will give you the speed. If you substitute the speed into this equation, all you need to see that the meter reading before and you subtract it from 26862, will it be a palindrome or not? Whenever it's a palindrome, that has to be your answer because they will not give you 2 numbers, right? You know you cannot form an equation here. You only need the speed. That is the only missing thing. Substitute the answer options and check if the condition is satisfying. So straight away, what do you check for? And you know that if the story is selling palindrome, you have to use that palindrome somewhere in the movie, if that is the most important thing. So straight away, your job becomes very easy. Put pen to paper, next step, write only what is required. 26862 minus, first option is 110. Substitute 110 into 8 hours. 110 into 8 is 880. 26862 minus 880, right? So what happens there? What is the number that you get? 25982. Is 25982 a palindrome? No. From left to right, it is 25982. From right to left is 28982. Next option is what? 100. 26862 minus 8 into 100 is 800. 26862 minus 800. What goes? The 8 becomes 0. The number becomes 26062. 26062 from left to right. 26062 from right to left. It's the same number. So that is your answer. Do you need to substitute the rest of the options? No, because only one answer is correct. Straight away you can go for this. Yeah. So you saw what you need, what you have. You saw what you need. And then in terms of building a bridge as we discussed in the steps is also using the answer option, right? This is again a CAT problem, a very, very recent CAT problem, right? So the answer on this one, 26062. How do we build the bridge? Using the answer options. Next problem, again, it will take some getting used to, but I'll show you the problem, pause the video and use the same process. By selling 14 sweets for $1, a shopkeeper makes a loss of 40%. How many sweets should he sell for $1 in order to make a profit of 20%? Okay, so that's what they're saying. Now, what do you have? Selling strategy A, 14 sweets for $1. What is the selling price here? It's at a 40% loss. So if you're taking the cost price as X, then the selling price is what? 0.6x. 60% of that is 0.6x. What else do you have? You have the selling price B. Selling price B, what do they want to make finally? 20% profit. If cost price is X, then you need how much? 20% profit means 1.2x, right? What are they asking you for? They're asking you for the selling strategy B, right? I sold 14 sweets for $1. What should the shopkeeper sell? Now, if you look at how to build the bridge, you have everything. Earlier cost price is how much? 0.6x. Earlier selling price is 0.6x. New selling price is what? 1.2x. That means you're doubling the selling price. If somebody is doubling the selling price, that means what? What you're getting, the same quantity will become half. If I'm doubling the selling price of a kg of something, that means for the same amount, how much will I get? Half kg, right? Similarly, selling price is doubling, so the amount sold has to become half. He was selling 14 sweets for $1 earlier. If the selling price is doubling, how much for $1? 7 sweets, right? Not writing equations, not doing anything, just logically thinking through. Selling price is doubled means quantity you will get will become half. You might have thought that all the previous problems, no, sir, has some shortcut or the other is there. So, but what about a regular problem? If I have to do it in a linear fashion, there is no shortcut. Even then, the same process applies, right? So, we're looking at this. The salaries of 3 friends, Sita, Geeta and Meeta, are initially in the ratio 5:6:7. So, you know the initial ratio. In the first year, they get salary hikes of 20, 25 and 20. So if I take 5x, 6x, 7x, then every year I know the hike that they got. So from the first year, so end of first year, whatever is the salary, I can calculate it in terms of x. Second year, Sita and Meeta get salaries hikes of 40 and 25. The second year, Sita and Meeta's hike, you don't know Geeta's hike, right? So Sita and Meeta's salary is second year, you can calculate. And the salary of Geeta becomes equal to the mean salary of 3 friends. The salary hike of Geeta in the second year is what? So, what do you have? Year 0 salaries of S, G and M. So, 5:6:7, you take it as 5x, 6x, 7x. Year 1 increments 20, 25, 25, 25, 20. So, you can calculate the year 1 salaries at the end of year 1. You can get that value in terms of x. Year 2 increments of S and M. So you know that for year 2, S and M salary also you can calculate. Third thing you know is year 2 salary of G in terms of S and M, because it's an equation. You have year 2 salaries of S and M in terms of X. You know G is equal to the average of all 3. So G is equal to S salary plus again G plus M salary divided by 3. That means you can easily calculate G's salary also in terms of X. You know 2 people's salary and the third person's salary is given in terms of them, so you can calculate that also, right? So G's year 2 salary in terms of X, you can easily calculate. What do you need? All you need is the year 2 increment of B. So you know year 1 B salary, you can calculate year 2 B salary, percentage increment, you can easily calculate. So once you know that, that you need to do this, that you can need to calculate the year 2 this thing, and you can calculate increment percentage. Now before this, there is only one thing you need to figure out. You can think, sir, calculation will become tricky. Why is calculation tricky? Calculation will become tricky if you take 5x, 6x, 7x. When will calculation become easy? Take numbers. 50, 60, 70. When you take the numbers, so this is where in that how to build that bridge also, you have to think what is easy. 5x to calculate this 25%, 20%, it's a bit tricky. So better do this. So straight away I know that instead of taking 5x, 6x or 7x, 50, 60 or 70, definitely 50, 60, 70. Now on paper, when I'm going to calculate, I will always write only what is required. I'm not going to write every single thing. 50, 60, 70. What are the year 1 increments? 20, 25 and 20. So 50, 20% increase. 50, 1%, 10% increase is 1 decimal point inside 5. 20% increase means 5 into 2, 10. So 50 plus 10 is what? 60. 60, 25% increment. 25% is always how much? 1/4, right? 60 by 4 is how much? 15. So 25% increase means 60 plus 15, that is 75. Second part, 70 is also 20% increment. 1 decimal point inside, 10% of 70 is 7. 20% is 7 into 2, 14. So 70 plus 14 is 84. I will do all of this mentally and I will write this 60, 75, 84. Year 2, what do I know? I know that Sita has 40% increment. 40% on 60. 10%, 1 decimal point inside is 6. 40% is 6 into 4, 24. 60 plus 24, 84. Geeta, do I know? I do not know. Do I know Meeta? Yes. Meeta is 25% increment in the second year. 84 25%. 25% is again what? 1/4. 84 by 4 is how much? 21. Right? 84 plus 21 is how much? 105. So I know that here too, 84, x and 105. Now the third thing, I know that Geeta's salary is equal to average of the three. So if I want to know Geeta's salary, and I've already taken it as x is equal to 84 plus 105 divided by 3. Now instead of writing this, I will do a few things mentally. 84 plus 105 is how much? 84, 105 plus 84 is 189. So 189 plus x divided by 3 is equal to x. I know that this 3 will go here, 3x. I know that x will come this side. 3x minus x is how much? 2x. So I will actually write 2x is equal to 189. I won't do the whole thing. I might also not write that. I will do the calculation, but just to not make it seem very scary, I'm saying. So you know that you're adding these two, dividing by 3, 3x will happen. Do these steps mentally. It might seem very taxing now, but it will become very, very easy. 2x is equal to 89, means x is equal to what? 189, 189 by 2. What is 189 by 2? 189 by 2 is 94.5. 94.5, 189 by 2. So the increment is how much between 84.5 and this one? 94.5 and 80 and sorry. And how much? 75. Sorry, it's not this thing. So because the amount of Geeta's salary is 75. 75 and 94.5. 75 plus 20 is 95. 94.5 is 0.5 less, 19.5. 19.5 by 75. How do I do the calculation? There is the calculator. You want to use the calculator? Use the calculator. But I would want to do it using this thing. So from the options, I know the options are 23, 25, 26 and 28. So I need to start from 20 and then go up. So what do I know? 7.5 is the denominator. So I need to know what percent of 75 is 75. 75 is the denominator. What percentage of 75 is 19.5? 10%, 7.5. 20%, 7.5 into 2, 15. So it's definitely more than 20, right? What is balance? 4.5 is left, right? So 7.5 is 10%. You need to find out what is 4.5, right? Half of 7.5 is how much? 3.75, right? So that means already 20% plus 5% is 25%, 3.75. Out of 4.5, how much is left? 0.75. 0.75 is 1% of 75. So I need 20%, 5%, 1%. That is 15 plus 3.75 plus 0.75. It's 26%. You can aram se use the calculator. Absolutely nothing wrong with it. You can also do the cutting of each of these things. 5 goes 25 times. 5 goes 39 times. And all of that. So you can do 5 goes 15 times. You can do all of that. Right? Now, absolutely fine. So answer on this one, 26. That's what you have, right? So even in a very regular problem, once this becomes a habit, knowing what you have and what you're missing, you'll see that the process becomes very, very systematic. Yeah? What are they saying? Anil invest 22,000 for 6 years in a certain scheme with 4% interest per annum, compounded half yearly. Now, compounded half yearly means what? Usually the formula is P into 1 plus R by 100 whole power N. P is the principal, R is the rate of interest, N is the number of years. What happens when it's compounded not yearly but less than that, right? So if it is simple way to do is, if I'm saying your interest per annum is 4%, so for half a year, how much will be the interest if it's half yearly? Half of that. If it is compounded quarterly, that means interest is not per annum, interest is 4%. Half yearly interest will be 2%. Quarterly interest will be by 1%. If it's compounded every 3 months, right? That means it's compounded every 4 months, not quarterly, but every 4 months. That means 12 years, 4 months means 1/3. So interest will become 1/3. So whenever, if you're confused about, sir, I never remember the formula, you just look at the interest should become whatever, per portion of it. It's compounded half yearly, interest becomes half. Compounded quarterly, interest becomes quarter, right? Now, what does compounding mean? That at the end of the term of compounding period, on that the next interest is calculated, right? So for example, year 1, if it's compounded annually, year 1 you'll pay so much, year 2 you'll pay interest on that also, right? If it's compounded half yearly, what happens? 6 months one amount is calculated, that amount again becomes this thing. So if it's compounded yearly, the compounding happens once. If it is compounded half yearly, compounding happens twice. If it's compounded quarterly, compounding happens 4 times. So it's fairly simple. So in this problem, what do you know? If you have 22,000 rupees for 6 years, compounded half yearly, interest rate will become 2%, and it's compounded how much? 12 times, because every year, half yearly, 6 years, 12 times. Now, Sunil invests, I explained all of this so that, anyway, if I'm explaining a problem, I might as well explain the concept. Sunil invests in the same scheme for 5 years. So, Sunil is doing the same thing. He's investing in the same scheme of 5 years, so he gets an amount. And then reinvests the entire amount received at the end of 5 years for 1 year at 10% simple interest. So, this amount at 10% simple interest. Simple interest is very, very simple. At the end of 1 year, 10% means it becomes 1.1. If the amount received by both at the end of 6 years are the same, then the initial investment made by Sunil in rupees is how much? Now, what do you know? You know you have Sunil's principal, interest rate and time. You have that. So, you know that you can frame an equation with how much money Sunil is going to make. You know that you don't have the principal, you have rate, interest and time. So you know that 5 years, whatever is the amount, you take it as X, make that formula for 5 years and just multiply with 1.1, because in the last year it's a simple interest. So whatever that amount is, that becomes 1.1 times. Both amounts are equal. So you already know that this is equal to this, the left hand side is equal to right hand side. What do you need? Anil's principal. So actually here, you don't need to build the bridge. Why do you don't need to build the bridge? The bridge is already given. One equation on the left hand side, all values. Another equation on the right hand side, all values. Only one thing is missing, X. But what is the tricky part here? Tricky part is that calculation. Everything raised to the power of 12, right? Because 6 years is compounding means, half yearly means, 1 year means it's compounding 1 time, half yearly means it's compounding twice, 6 years that is raised to the power of 12. This side, it's getting raised to the power of 5 years, right? He's doing it. 5 years compounded half yearly means 10. This might seem scary. So whenever the calculation is seemingly lengthy, don't get scared. Visualize the end game. Like in chess, people are visualizing the end game as to what is going to happen. Sometimes you have to visualize the end game. If you visualize the end game, for you to visualize it, you know that for both of them, the interest rate is the same. Only the number of years are differing. So if you just visualize that in terms of put to pen paper, write only what is required. You know that this is 22,000. Whatever is that amount, 1 plus r by 100, whatever, that is raised to the power of 12. Here, Anil's amount you don't know, that is X. Whatever is that interest rate, here it is raised to the power of 10. So straight away, what do you know? This x power 10 and x power 12 will get cancelled. It will just become x square. That's it, nothing else. And what do you know about that part? You know that it is, I think it's 22,000. That's it's my bad. So it's 22,000 into 102. So why did I make it 20,000 into 102? I said don't do all the calculations. No. So from here, now look at this. What do? I'll cut off x power 10 and x power 12. So that is x square. 1.1 will go in 22 how many times? 1.1 into 2 is 2.2. 1.1 into 20 is 22. So I'll cut that, that will become 20,000. So 20,000, A is equal to how much? 20,000 into x square. What is x? 1 plus r by 100. Half yearly means interest rate becomes half. 4% becomes 2%. 1 plus 2 by 100, that is 1.02. Square, that is 1.02 into 1.02. That is 20,000 into 1.02 into 1.02. That becomes 20808. So for this, you can aramse use the calculator. I don't see a reason why you need to, not use it, because it's a bit of a painful calculation. So, why to do that? Now, just because we're discussing this problem, this is a theta question, right? Again, very recent CAT question. This is a theta question. You had to, type in the answer. So why this compounding half yearly, right? If you don't compound half yearly, this would be what? 1 year means 20,000 into, if it's compounding yearly, it is only, once. It will be what? Take the same amount. Compounding half yearly is 20,000 into 1.02 into 1.02. Compounding yearly means 20,000 into 1.04. What is that value? 20,800. Right. So whenever you are compounding more frequently, it's a small difference only. 20,808, 20,800. That's only because the amount is 20,000. Once the amount is larger, it becomes this thing. Right. So the more frequently you compound, the higher the interest. Yeah. So my friend has a very, very famous what you call it's in the south. It's a pretty established sari brand. So whenever they give discounts on their saris, they don't say 20% discount. They say 10 plus 10. Why 10 plus 10? Because if you have 100 rupees, first 10% discount means that becomes 90. On that 90, if I give 10% discount, it's 9. So total discount given is how much? 19 rupees. But on 100, if I give 20% discount, how much is the discount? 20 rupees. Right? So they always do this. That compounding always either increases or decreases the value depending on whether you are getting an interest or whether you're doing a discount. Yep. X can do a piece of work in 20 days working 7 hours a day. Right? 20 days working 7 hours a day. Now this is what I was referring to earlier when you said the moment you see 20, don't type 1 by 20. Leave it there. Right? Work is started by X, and on the second day, somebody with twice the capacity of X is joining. Second day, he's twice as good. So if X can do some work, he can do twice the amount of work in that day. Third day, somebody else joins who can do thrice the work. Now it goes on until this work is completed. In how many days will the work be completed? If everyone works for 4 hours a day, right at the end, there's a twist. Not for 7 hours, but 4 hours. Now what do you know? What do you have? You know the total number of man days required for the job X or man hours required for the job X is 20 into 7. It is 140 man hours are required for this job. Whenever 140 man hours of work is completed, the job is completed. If X is working 20 days, you need 20 man days. But here in this situation, what do you know? Everyone is now working only for 4 hours. If people are working for fewer hours, if X only, instead of working for 7 hours, X is working for 4 hours, that means the number of days taken will be higher. Now in the new situation, what is the number of man days required to finish this job? 20 into 7 divided by 4. Total man hours is 140. People are working only for 4 hours a day. 20 into 7 divided by 4. Right? So 4 goes 5 times, 35 man days. So you know that 35 man days are required to do this job. What do you need? In how many days will the work be completed? So whenever 35 man days of work is completed, if X alone is doing, 35 man days of work is required, right? Whenever this 35 man days of work is required, it's completed, the job is done. Now you go to this thing. How do you build the bridge? Whenever 35 man days of work is completed, job is done. Day 1, what is happening? X alone is working. How many man days of work will be done? 1. Because X alone is working. Day 2, X is there and somebody twice as good as him is coming. So if X is working, it's 1 man day. Somebody twice as good as coming means 2 man days of work is done. So on day 2, how many man days of work is done? 1 plus 2, 3. Day 1, 1. Day 2, 3. Day 3, what is happening? These 3 man days of work is getting done and somebody who is thrice as good as X is coming in. That means that guy can do 3 man days of work in a day. So day 3, all 3 together, how many man days of work is done? 3 plus 3, 6. Day 4, 6 plus 4, 10. Day 5, 6 plus 5, 10 plus 5, 15. So whenever this total number of man days adds up to 35, the job is done. Right. So started by X, 1 day, second day. So we've discussed this. So day 1, 1. Day 2, 1 plus 2, 3. Day 3, 3 plus 3, 6. Day 4, 6 plus 4, 10. Right. Now this total is how much? 1, 3, 6 and 10. This total is how much? It is 1 plus 3 plus 6 is 10. 10 plus 10 is 20. Total required is 35 man days. So this thing. Day 5, somebody with 5 times is getting added. 10 plus 5, it is 15. So 20 plus 15 is 35. At the end of 5 days, the 35 man days of work is completed. We've calculated that X alone, if he's working 4 hours a day, he needs 35 man days. X is there. People are joining him. Day 1 he's alone. Day 2, day 3, day 4. Whenever this total of man days becomes 35, it becomes this thing, right? So we looked at what is there, and again we looked at how to build the bridge. Going back to summarize once more. Step 1, read the question fully. Do not put pen to paper. Step 2, what do I have? What do I need? So that sometimes we miss, in terms of exactly defining or understanding what do I have. What do I have is not just what is given, but also knowing what can I easily calculate from that. Step 3 is between what you have and between what you need, how do you build that bridge? Step 4 is putting pen to paper. Then you start writing and write only what is required. Step 5, before marking, check what is being asked. These are the 5 steps for any quant question. If you do this, you will see that the process becomes very, very smooth for you, right? This is the first video in quant that I'm doing called How to Solve a Quant Problem. In the next video, How to Learn or Learning to Learn Math, I'll look at how, say, people with who have a problem, with math, so who've had a bad experience with math or who always been scared of math, how can they actually learn math better? And in the last one, I'll look at all the shortcuts and the intelligent elegant solutions. That one's called the elegant solution, right? So first, establish the basics that irrespective of what you learn, whatever the concept, this is how you solve. Second video, to teach you how to learn. Last one, now that you have put your feet on the ground firmly, you know how to solve and you know how to learn, then how do the shortcuts come in? How do you start flying? How do you start doing the gymnastics, right? So I hope this video was useful, and I hope when you start solving questions from now on, you will just follow the process, right? Thank you.